In this video, I'm going to give you two short examples of doing hierarchical clustering and k-means clustering using SciPy package, SciPy library in Python and sklearn basically. And in the first example, we are going to solve a problem that could be seen as a real-world problem. And we have a data set called shopping data. You could follow the link to this code and the dataset is found on the description box of the video. And the problem that we are going to solve here is to segment customers into different groups based on their shopping trends. So let's first import the libraries that we are interested in, and at the first stage I'm going to import Matplotlib, Pandas, and NumPy. Then we are going to export the dataset that we would like to work on. That is the shopping dataset. Let's get a bit of knowledge about the dataset that you're working with, and the first step, what's its shape, and what you're seeing here is basically telling you that the dataset contains 200 samples, 200 subjects, and each of them have 5 different attributes. And here is a bit a portion of the head of the dataset. You could see the customer ID, their gender, their age, their annual income, and their spending score. What we are going to do here is, because we want to view the result in two-dimensional feature space, we keep only 2 of these 5 attributes. We can remove customer ID column, gender and age column, and then we only keep annual income and a spending score. And by spending a score, we basically mean how often a person spends money in a mall on a scale of 1 to 100, with 100 being the highest spender. So I'm going to run this piece of code to get only the last 2 columns that I'm interested in. And then what we need to do is basically we need to know the clusters that we want our data to be split to, and we use SciPy library to create dendrograms for our data sets. So I'm going to run this code here and plot the dendrogram at the same time. Yeah, it's ready. In the code that you saw here, basically the hierarchy class has a dendrogram method which takes the value returned by the linkage method on the same class, and the linkage method takes a dataset and the method to minimize distance as parameters. We use word as the method since it minimizes the variance of distance between the clusters. So the output looks something like this, and if we draw a horizontal line that passes through the longest distance without a horizontal line, basically somewhere here, we see that we are going to get 5 clusters as shown in the figure really here. If you draw something here, then you have 1, 2, 3, 4, and 5 clusters. Now we know the number of clusters in our data set, and the next step is to group data points into these 5 clusters. And to do that, we will use agglomerative clustering, which is a bottom-up clustering method from a sklearn library. As you see here, the output will look something like that, and you could see the cluster label for all the data, and since we had 5 clusters, we had 5 labels from 0 to 4. And as a final step, we are going to plot the clusters to see if our data has actually been clustered properly the way we wanted it to be clustered. And as you can see, the data point have formed 5 different clusters, and the data points in the bottom right belong to the customers that spend have the highest salary with lower spending. These are the customers that spend their money carefully. Similarly, the customers at top right, the green data points here, are the customers with high salaries and high spending. And these are basically the type of customers that advertising agency companies and whomever is selling something is targeting them, the people with money who are willing to spend. And the customers in middle, basically the ones with average income and average salaries. And as you see, the largest number of customers belong to this category. These are actually also some of the customers that companies target because they are huge in numbers. Basically, they are more than the people in this green cluster, for example. But as you see, I mean, when you're doing clustering, you need to interpret the data. And as I said already in the previous video, the interpretation could be quite subjective. And it also depends on what you have in mind. I mean, in this scenario, we are thinking about perspective of the companies who are targeting customers with their advertisements, with these promotional items and all these things. But there could be some other problems when the modeler is basically interested of low income, low spending money, or low income, high spending money, which could be a problem group because they are basically spending more than what they are earning somewhat, or they are not spending carefully. And then these people, if we think about giving them credit, probably are not the ones that you generally want to have as your customers when you're targeting to give credit to someone. So this was how hierarchical clustering was done. In the next example, I'm going to give you a small example of how to do k-mean clustering. Okay, so what we do first, we import the libraries that we are interested in, and keep in mind that we want to apply k-mean clustering with scikit-learn that generates convex and isotropic clusters. Basically, these are the clusters, putting in plain English, that are separable and equally wide and height. So let's import the libraries. Of course, I have already imported matplotlib and numpy earlier, so I'm only importing makeblobs and k-means here from scikit-learn dataset and scikit-learn cluster. But remember that if you want to do only k-means, you need to also import numpy for number processing and matplotlib for visualizing the clusters. Now that, let me import this, I forgot. Now that we have specified the imports, we need to do a bit of configuration before getting any further. And we are going to go somehow simple. We are going to generate 1000 samples in total. We're seeing it here. And they will be spread over 2 clusters, the first of which is located approximately at the coordinate 20 and 20, and the other one at the coordinate 4 and 4. And the number of classes, or the number of clusters, is pretty obvious. That's going to be the length of cluster centers, which is 2 at this point. And then I'm going to generate the data, and generating the data simply means that we call the make blobs definitions from scikit-learn, and it does all the hard work. We specify the centers in this code and the number of samples that we configured before, and as well as a number of features, and we set a standard deviation of 2, which means that the samples were generated at those 2 locations and distributed around the centers with the high likelihood of a deviation of plus minus 2. So let's do that. And if you want to save the data so that you can use the exact positions later, you could add this code as well to save them, but it's not really necessary. So on the fun parts, the easy part basically, as you saw before, what we do simply is to initialize the model, which is a k-mean model, and we choose the random or k-means plus plus, whatever that you would like to say, and then the number of clusters and an initiate. So let's do that. And what it does is basically it's a number of the times that the k-mean algorithm will be run with different centroid seeds, and the final result will be the best output of n init consecutive runs in terms of inertia. Let's see. So I have done that, I have fitted the model, and now it's time to actually do the real fitting, which is predicting the clusters for all the samples. And now, final step, we want to see how it looks like. We want to generate visualization with 2 classes colored differently. And I think the result is quite obvious. You immediately could identify 2 different clusters being put at the different locations that we already initialized at the beginning of the code. These 2 were simple examples of seeing how these methods are being done. As always, the idea is not really to go deep in one specific algorithm. The course is not about clustering. It's not about hierarchical clustering specifically or k-means. It's just to give you an overview to what is out there and what is it that you should look for when you are doing different data science approaches on different data sets, considering the nature of the data set that you are working with. This was it for today. I hope you enjoyed the tutorial and the video lectures. You could find the link to the video and the dataset in GitHub. I will add the link to the description box as well. Good luck with clustering, and see you in next lecture.